evening all. How we all doing? Hello, hello. Yeah, I've been having a bit of a mare over the past few days. We've got some circular dependencies which seem to have crept into the code in Unreal, and it's causing crashes left, right, and centre. So that's what I have been struggling with. And well, it's crashing right now actually, so we're going to have to fix that before we can do anything. So we'll get into that in a moment. Hello, hello. No, CSI. Sorry to say. So this is my life at the moment. Unreal crashes, and it's saying it's game state, but it seems to be related to the task manager system that I've been working on for the NPCs and refueling and all that stuff. And in order to get the information the game needs for knowing, like, is there a gas giant nearby? Are we even in a star system that has any gas giants? And all that sort of, all those questions that need answering for the logic to know what to do. Obviously, we have to query the game systems that generate that information. And in particular, one of them is our galaxy location generator, which is one of the oldest bits of code we have in the project, which was originally set up as a blueprint component which just sits on game state, and I placed it there out of convenience, because game state's replicated out of the box, and it seemed logical to put something that important where I can replicate it easily. And in hindsight, several years down the line, it's certainly not working out that way, which is why we moved the Galaxy Gen as a whole into its own isolated, independent actor. So I need to move that star system generation code, and that's just like the interior star system, the planets themselves and the moons and all that stuff, into its own separate actor outside of game state, which is like one of the core framework blueprints. Because we're casting to that via a macro in order to get the information we need out of it. And I think it's that casting via a macro library which is causing the problem, because every blueprint has to load the same macro library, and having that cast there, that hard reference to game state, and indeed a blueprint component sitting on the back of game state, I think that's what's generating this particular crash. So what I was about to do is replace our task manager with a backed up version of it, and then hopefully that will at least get us back in engine. So I don't mind deleting that, because I've already done this a couple of times already to try and get into things. So I've had to pull a version that was on Git, which was older. Let's just give that a try a minute. Yeah, this one's it's a tricksy one. I think the solution is to not have this stuff hanging out the back of a macro library. I think that's fundamentally where it all started breaking. Now hopefully I can load said macro library without the whole thing crashing. No. Okay. So that's the problem. Basically, within that macro library, we've got macros that are referencing things on game state as a hard reference. So let's replace them. If we grab one from earlier today, then that should be without the macro I just re-added. Because what it's doing is it's actually corrupting stuff at the same time. Because I had to replace game state with a backup as well. So we get rid of that one, replace it with that one. The thing I fixed was this, but I've also, separately to this, I've made a lot of headway with our PID controller for atmospheric flight, which I'd love to show you, and I will if I can get this to not crash. Can we now open that? Nope. Okay. Which would suggest that once again it has corrupted game state. Which is that one? That's yesterday's one. Yeah. So if we get rid of that a minute. Use that one instead. Just going to move that over there. Get it out of the project a minute. Right, let's give this a whirl. Yeah, it's been an absolute nightmare. This this system for the NPCs being able to like do the automated refueling and everything has basically hasn't caused the problem that we've got now. It's exposed the problem that we've got now. So basically we need to break those references that are causing these crashes. Yes, it's a different memory address each time as well, which is not helping. And sadly, the logs are never particularly useful in this instance. So I did a Git backup of the project last night. So worst come to worst, I just restore from yesterday's backup. But I don't want to lose 24 hours worth of stuff. So hopefully we can cherry pick what's broken. Okay, if we delete the game state a minute completely and see whether that lets us get into the macro library. Obviously, there's going to be a bunch of broken references, but if it at least breaks the cyclical reference chain, that should at least allow us to open something. Yeah, there we go, that's better. Okay, yeah, so this get current subsector, what this is doing is obviously it's getting a reference to game state and our galaxy location generator, and then just getting the details for the local system that we're in. But this is what's causing that hard crash. Now it's going to basically give us a bunch of broken references on here as well, but if we could at least just delete that. And I think the reason it's breaking is not because we're casting to game state, because that's never had a problem in the past. It's because we're casting and getting a blueprint component which is hanging off the back of game state. That seems to be where it's falling on its face. So if we were to get and record this variable on game state itself, as opposed to the component attached to it, that will probably be fine. So if we just save that and nothing else, and then we'll put game state back again. Hopefully that wasn't one of the corrupted ones. Hey, Delta. Right, let's try an older backup of game state. Right, moment of truth. Can we open game state? Nope. Okay, so next test then. Let's get rid of... Hang on, find the right folder. But let's just delete that a minute. Because what was happening is it's corrupting more than one blueprint. when it does its crash. So obviously every blueprint that it touches gets corrupted, and there were like 45 of them, which was an unpleasant job going through them all. So if we also then get rid of that macro library, it's all good. Like, I wasn't going to stream this because obviously, who wants to watch something broken? But I figured this is part of game dev. You know, sometimes things break, and you know you just have to put the time in and the effort in to fix whatever the problem is. So you know, it's that whole kind of warts and all thing. This is part of my job, is dealing with stuff like this, so you know, why not show it? Right, okay, so this particular access violation, this one is like a dependency thing. Right. Okay, so if we also get rid of game state, so we should be able to get into a blueprint now, and if we can, then I'll put back an older backup of game state and we'll see whether or not that opens. Let's just do that macro library. Right, so that one opens, and I would assume then from that they'll all be opening. I don't know, let's just grab one of the bigger ones. Chairmaster, that's a particularly big one. See whether that actually opens. No. Okay, so what's that crashing on? Nothing in particular. Okay, so if we give it its macro library back, and then we'll try that chair again. And we'll do the backup from a couple of days ago. Because this is the question, basically. It's when it crashed and when things got corrupted, it's like how far did that corruption actually spread? Last time, it was literally just game state and the task manager. I'm hoping it's just a combination of those two again this time, but we shall see. Right, so first things first, can we open the macro library? Looks promising. Yes, we can. Okay. Right, so this has get current subsector in it, which we don't want. I'll leave it for a moment, let's just see whether or not we can open that chair. Yes, we can. Right, okay, so yeah, so it's not that this particular blueprint is corrupted, it's because the reference chain was corrupted. So now we need to work out which order to put things back in to keep it from crashing. I think I'm tempted to use a much older version of that macro library. So we get rid of that one and go with our oldest backup of it. Let's go with that one. Obviously I've added a few things to it, but I can always recreate those macros if need be. Let's just see what's in that one a minute. It's true, actually. Windows Update did its thing and now everything's broke. Interesting. Let's try that again a minute. I think I had an old error message up because it's referencing game state, which I deleted, so it can't possibly be referencing that. Oh yeah, just a memory error. Right, okay. So, interestingly, I think the only surefire way really of fixing this is to replace those files from the Git backup from yesterday. And hopefully it was just those ones that were corrupted. So bear with me a minute and let me just do that. I shall be back. There we go, that fixed it. So interestingly, I restored just those 3 files, the game state, the macro library, and the task manager. And the 3 files that I took from Git indeed fixed the problem, but interestingly, not from the autosave, which is weird. Why would do that? But yeah, it worked, so hurrah. Another victory for having Git versioning. Right, so assuming it doesn't crash when I press play, make sure we're on client. Yeah. So you might notice that the shuttle has some green thrusters underneath, and I'm able to shove it around like this. Like Flight of the Navigator style, because it now has landing thrusters, and these landing thrusters are they're using a PID controller to basically keep the shuttle upright and in a stable hover. And I've basically set it up so that the shuttle is effectively an FPV drone. So it's using like the same kind of PID that an FPV drone would use. One issue at the moment, as you can see, as I'm standing in it, it's not very resilient to physics actors like being inside of it. It needs to cope with that dynamically. Right now, it's not doing that. It's just trying to sort itself out. It doesn't know how to respond to shifting weight on board. But once we're in the seat and the player no longer has gravity, then we can actually fly quite happily. So because it's basically a quadcopter, like if we tilt the nose down, then obviously we start going forwards, because it's using just those 4 thrusters to keep us airborne. Similarly, if I roll to the side, then we'll start sliding sideways because we're using that same 4 points of force to keep us aloft. So when we're deciding how we want shuttles to handle and feel, and indeed any atmospheric vehicle, we obviously want to simulate them as much as we can within reason, so that they are actual, properly simulated vehicles, without making it too extreme. So like I said, we're not going to be doing actual aerodynamics or anything like that. So we won't have wings or lifting bodies. When it comes to that, we will have a simulated version of it. But I just wanted to demonstrate how well it recovers from an upside down situation. So again, the only thing keeping us upright and keeping us in the air is the PID controller and those 4 landing thrusters. That's it. It has full gravity. It will fall to the ground if you turn them off. So if I turn upside down, then you'll see it will now start to plummet because the thrusters are now underneath, so I'm pushing us down. So now it will try and recover from that drop and level us off. And it did that with me not touching the keyboard. So it's able to recover the situation. So when it comes to the flight model and how these things handle, it's going to be a bit of a learning experience, I think, before we find the sweet spot. So you can still use obviously the main engines to thrust forwards. So I guess it's like a jet-powered drone. So I can still, quite happily fly around. And stop. It's certainly a lot more controllable compared to what it was a few days back. The lateral thrust is a little bit weak, so that needs sorting out. But if we just slide on over here, we should be able to land quite happily on the beach. so. And I can hop out. It'll drift away from me. No, 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 don't get me in the water. Stop it. No, no, over there. Yeah, so it will just kind of bob around on its landing thrusters. Obviously, we need to have it turn them off once you're on the ground. But yeah, you kind of get the idea. It's trying to keep itself aloft and straight. So I've given it essentially two priorities, which is one, be the right way up, and then two, arrest any vertical velocity. So the PID controller is literally just doing those two things. If you enter any kind of control input, that will override the PID controller, so it always prioritizes player input. Obviously, I'm doing this with a keyboard, which is not ideal in a simulated vehicle. I'm sure with a HOTAS this would be a hell of a lot easier to fly. But that aside, it's not terrible to fly. It's definitely flyable. Let's see if I can fly around this peak over here. Yeah, see, that wasn't terrible. You do lose a bit of altitude, so I keep having to kind of tap up to try and restore that, but my goal for this is I wanted to be able to do canyon runs, and obviously without wings and aerodynamics, it's difficult to do a canyon run with basically quadcopter physics. Oh no, up, up, up. No, don't hit the trees. Okay, that wasn't quite as smooth. But yeah, I think we're definitely... Oh, no, wrong button. No. Ah! Uh-oh. It's all gone wrong. Oh, yeah, hit a tree. Yeah, it's easy to get wrong. What I like about it, though, is that flying the vehicle in atmosphere does take a little bit of nuance. It's easy in the sense that if I just take my hands off the controls, it will simply drift to a stop in midair and hover on its own. Similarly, if you kind of get it wrong, it will recover from any bad situations. So it's easy to fly in that sense. But at the same time, if you if you fire the thrusters and aim it at a mountain or something, obviously the controller knows nothing about that. All it's trying to do is stay upright. So getting out of those situations can be a little bit tricky. It will obviously, if we use the main thrusters and point up. Okay, so every time I take my finger off the controls, it's obviously trying to right itself again. But yeah, we should be higher up. So we should be able to fly reasonably high. Like a virtual horizon or something would be useful at this point. In fact, a HOTAS would be useful at this point. So yeah, we've definitely gained some altitude, but yeah, it definitely fights you if you try and go upside down. It really doesn't like being upside down. It's like, no, just let me be the right way up. Ooh. Yeah, so it's definitely tricky with a keyboard. I think this is the kind of nuanced flight engine that does require finer inputs than what our keyboard can provide. I've tried to ramp up the key inputs slowly, so it's not just going like 100%. Tree. Yeah, and the upward thrust is it feels that it can like lift fairly rapidly when you're down at ground level. When you're flying towards the ground at a rapid pace, it feels that the upward thrusters are quite weak. So lots of tuning is going to be needed before we can sign off on this as being a releasable flight model that people can actually get to grips with. But it's a good start. It means that I guess the important point is that the flight model, both for sublight and atmosphere, are almost done already. And this is one of the things that we wanted to do in the next update when we were doing sublight. And we've gotten to the point now where that work is practically finished. So kind of we're ahead of ourselves for once on a feature, which is nice. So I guess what comes next with this is making sure that the autopilot can fly it as well, which shouldn't be too difficult because all the autopilot's going to do is basically point at a vector. It's already got the capability to do that. So we'll give it an up vector in space, so we'll use the orbital plane of the star system as its up direction, so always aligned to that. And then it will just use the RCS thrusters to point a particular location in space. And we'll do the same for surface locations as well. So if we wanted to pinpoint a particular location over there on the coast, then we can make sure that the autopilot can get the shuttle there in one piece without crashing. I mean, I can barely do that without crashing, so it's definitely going to be a challenge for the autopilot. When I put out the next test build, I might stick this level out as a standalone thing on the dev build, so you can get onto it and just have a play around and let me know what you think, because I'd like to get some feedback on just how it feels to fly. I mean, I guess I've gotten used to it now, so I'm kind of okay with it, but like if you wanted to be more precise than just flying around, it does get a bit twitchy. But we managed to fly over here to an object, so that's something, I guess. Oop. Oh, no, sit still. No. Just let that drift out to sea, I guess. But yeah, so we definitely made progress with it, and it's definitely flying. So that's that's an improvement for sure. The stuff that's floating in the water is just part of this test map. So this whole map is the Shader World test map that comes with the plugin. We're using Shader World for our terrain rendering. Well, I say we're using it. It's one of the candidate systems. There's a few different systems I'm looking at for doing planetary rendering. Shader World is good because you can just fire height maps and things at it really easily, dynamically. We're also looking at Voxel plugin and a few others just to see basically I'm playing them off against one another to see which one has the features we need and the performance we need in order to generate planetary surfaces quickly and easily. One of the things that Shader World lacks, in this version at least, it doesn't do nanite tessellation on terrain. I think it's using parallax occlusion, but I really need nanite terrain, so we'll look into that. But yeah, there are various different things, but it might end up being this one, it might be a different one. Either way, it will look like this. So we will go for fully lush terrain. Only we'll be using nanite trees and stuff, so obviously these are LOD based trees with masked textures as leaves and branches and stuff. Nanite foliage is all 3D models, so we'll be using that. But that aside, you can expect surfaces to be, this cluttered with stuff. So the other thing we need to do from a shuttle perspective is we need to have all of the component pieces be separate objects with their own collision. And in order for them to work as a component in something which is movable, obviously they need very specific custom collisions. So we'll have to build those in. Floor plates and things are easy because they could just use a simple box collision. I think I'll probably combine those into one panel, and these as well. I'll stick these as one panel, and then we need some anchor points throughout the shuttle for snapping the geometry to. If you want to see it in multiplayer, I'll give you a demo. Fair warning, it's a little bit... Oh no, wrong button. It's a little bit dodgy in multiplayer. It's using predictive movement to move stuff around. So if I just quickly hop on here as the host so that we're in control of it and it doesn't zoom off everywhere. And then if we grab the client window, so here's the client. So the client can see that the host is in the shuttle, and they can see everything there, and you can see the client in front of the shuttle. It's all working in multiplayer. Lateral movement works absolutely fine. Horizontal movement does not. So I'm going to have to minimize this a minute actually. Let's make this window smaller. Okay, so if I go forward a bit on the host, you can see that the shuttle does move from the perspective of the client quite happily. So that's good. So lateral movement is fairly well synced. If I go up, then the shuttle completely goes mental. It really doesn't like vertical movement at all. It doesn't help that I hit a tree. Hang on, let me get that back. Got to find out where I was parked now. I think I see a person. Yeah, there we go. Yeah, so you can see on the client machine, the movement is really nicely synced when you're just flying about the place. it's that horizontal, that vertical movement where it completely falls apart. Otherwise, it's perfect. So if I try and go down now, you can see that. See, it just doesn't handle vertical movement at all. It will recover, but from a being inside of it perspective, that would not work as a client at all. Yeah, if we turn around and zoom off, you can see how fast the thing is. It's actually quite nippy. And you can see it on the client side, like ground clutter and stuff is disappearing. It's another issue we need to solve with multiplayer and terrain, is that the terrain is drawn from the perspective of the host. So we just need to make sure that that's sorted out. I've no idea where the client was now. Oh, I'm close. No, lost them. But anyway, you get the idea. So yes, it kind of works in multiplayer, unless you just avoid going up and down, and it's fine. But what we'll probably have to do is turn this into a pawn rather than an actor, and then we can do like proper possession of it and move it around properly with proper movement prediction, because it just doesn't work properly as an actor. Yeah, surface persistence is a difficult one, because when you go down to a planetary surface, what it's actually doing behind the scenes is it's generating that planetary surface in a vertical slot underneath the main ship. So your main ship's interior is static, of course, and when the shuttle is in space, its interior is static. So we want it so that when you might have a planet that has a space station in orbit, it could have an alien derelict in orbit, any number of other things in orbit which are physically boardable, as well as the planetary surface itself. And we don't know ahead of time how many things we're going to generate surfaces for, or walkable environments for. So we need to basically have a slot reservation system whereby, like, every 1,000 kilometers below the ship, there's another slot available for generating either planetary terrain or the interior of a space station or anything else. So we are dynamically spawning in those environments in those vertical slot positions, on a first come first served basis. So we're never going to know in terms of world location where an object would be. So if you bring a watermelon down to a planetary surface and you plonk that melon down just on the ground somewhere, then obviously we could save the location of that watermelon with respect to the world. But when you return to that planet later, that planet might be generated in a different slot. So something else might have taken up the slot that it was in. You might have spawned another vehicle, and then the vehicle preserves that spot for its interior. So now the planetary terrain is in a physically different location to where you put the melon. So we would also then have to store offsets of whereabouts on the relative terrain is that melon sitting, and then simply spawn that in if you return to that location. So it's not impossible to do object persistence galaxy-wide, and it would be great if we could. Now, if you could put a cup on a rock like hundreds of light years away and return back to that same rock months later, it would be awesome if that cup was still there where you left it. And in order to achieve that, we'd have to take the seed of the planet as the unique ID and have a database of dynamic actions that you've taken on that planet per ID. So So we'd have to build up that as part of the save game. And obviously, every time you add something like this, you're bloating the save structure. So it would have to be an extra set of arrays that would have to be organized by planet. So for every planet you leave something on, that array grows by one more entry. So if you've been to 1,000 planets and you've left 1,000 things on 1,000 planets, then that array is going to grow huge as part of the save game. So no, it's not impossible, but yes, there are consequences. So we'll address that as it comes and see. We could always have things time dependent. So if you've put something on a planet 6 months ago, then chances are it's long gone by the time you go back. So we could manage the data structure in that way and have things kind of time out over time. But yeah, it's not impossible. It's definitely something we can mess with. The surface itself, as I said, this is just a test map. So a lot of it is, well, some of it's procedural and some of it's geometry stamps. So as I move around, a lot of this is geometry stamp. So this bit's noise, and like this bit here, this is stamped geometry. Which if I select that, I'm not sure which one it is. Is it that one? Yeah. So you can move this around, and this is one of the nice things about this particular plugin, is that you can literally move mountains instantly, and it will form the terrain around those geometry stamps. So from an authoring perspective and for a dynamic environment perspective, if we wanted to place an alien structure on a planet, then we can have a pre-made bit of geometry relating to that object. Say it's like an alien research outpost, then we can make sure that the terrain around that research outpost fits the outpost, and we're not going to have mountains sticking through the side of it, because we can use stamped geometry to ensure that our research outpost has the correct terrain to align with its buildings. So that's nice. So that just gives us that capability. Obviously we'd have to do that on the fly, and it's just another example of it here. If I can click on it, there we go. Again, so it's just basically just a bit of geometry which you are modifying the terrain with, and it does it in real time. So it should also stack as well, I believe. Yeah, so you've got two geometry stamps here now stacked on top of each other. So the effect is cumulative. So we can build up dynamic locations in that way. And you've got things like that for like biome stamping. You can use splines for like drawing roads and stuff, that sort of thing. And again, that should, if I can click on anything, let me select it. There we go. Yes, you can move roads and stuff around the terrain, and it will obviously create the terrain around the needs of the road. So obviously it creates ditches and things if need be, just to keep the road flat. This is more difficult to use procedurally. Obviously you'd have to draw the spline procedurally as well, and that's definitely a lot more of a challenge. So for the bulk of the terrain generation will be done with noise maps. I've already built a really good erosion system, which is using it's not true erosion, but it looks like erosion. So where you've got things like the gullies and things from the water erosion on rock faces, it's able to compute that as part of the noise algorithm, as opposed to actually doing noise computation, as opposed real-time erosion computation, which is mathematically very, very heavy and takes a while, and no good for real-time rendering. But you faking it through noise, where you can get a result which looks the same for much cheaper, is definitely the way forward. And then we just use, obviously, just geometry scattering over the surface. So you apply a rule set for things like density and a number of objects. This is using its own scattering algorithm that's part of Shader World, but we'll be using Unreal's PCG tools, which are a little bit more nuanced. And again, we'll be using nanite foliage as opposed to LOD static meshes. So where you've got, like here, you can see really obviously where geometry is swapping out LODs and casting shadows. This transition will be gone once we move to nanite foliage, because it will just voxelize the mesh itself. So the further away the tree is, the more it voxelizes with bigger and bigger voxels to reduce render complexity. But you lose, you don't get any popping in with that. It makes it much smoother and much nicer. So we should have millions of trees all the way to the horizon without any additional impact on GPU, which is very, very cool and very, very clever. Yeah, and that's it really. Obviously it's got a water system. You can go into the water. It does actually have like a camera thing. If you can get it in the right spot. Can't quite get it in the right spot, but yeah, almost there. But yeah, so obviously we want to have underwater environments as well. Claire wanted to be a marine biologist when she was growing up, and she's got a huge love of marine life and marine biology, so I think we definitely need to give her that marine biology experience by being able to fly shuttles underwater. But yes, obviously this particular terrain is just like a limited stamp of terrain, so it does run out after a while, just turn to just bare surface. But we have full control over how far it generates and obviously how far into the distance it renders. Right now it's set reasonably low, but we need to find the sweet spot in terms of when you're flying around in a shuttle, how high will the shuttle be able to go before it transitions back into the space location, and how fast can we move across the terrain? Because obviously the faster you go, the greater the impact is on it being able to spawn objects and generate terrain. We can certainly get to the point where it generates terrain much further away. But yeah, so I'm guessing speed-wise we'll probably have shuttles fly about this fast, maybe a bit faster. Again, I really want to be able to do kind of canyon runs and things. Yeah, I reckon this is probably about the speed that we'd cap the shuttles at. This feels nippy enough to be able to get around the planet reasonably quickly, without putting too much of a strain on like the forward generation of the terrain and the trees and everything. But we'll dial all that in when it comes to it. But yeah, I definitely want to be zooming around canyons like this in shuttles and other vehicles, because yeah, it's fun to do, and it'd be great to have races and things once we've got shuttles working in multiplayer, and you can have multiple shuttles down at once. Chasing each other through canyons in shuttles would be a hell of a lot of fun, I think. Okay. Lost the shuttle now. Where did I park it? It's around here somewhere. There it is. Okay, yeah, so again, we need to edit these interior bits of geometry now. Because right now, all of this is one solid object, and we need to start separating all the different pieces out to make them separate objects, so that they can be separate objects in the world that can be interacted with, removed, destroyed, that sort of thing. And these panels obviously need to be removable so we can get to the hardware behind them, and the same for the floor. Yeah, and I think I will remove the sub-D geometry in the floor area and just make that flat cutouts. So let's do that, and then we can start importing all that in. So first of all, let's undo the subdivision on that. I think what I'd be tempted to do is basically remove all these bits, and then we'll construct the interior floor as a separate bit of geometry, and then just leave the sub-D mesh for the curvy bits. And I'll probably do the same across here as well. We'll make this its own bit of geometry. But once we're done with the external skin, and we've truly kind of finalized the geometry, then I'll take the subdivided version and replace some of it with just flat faces like this, so that we can better work with it. Yeah, so I suppose we need to create those holes. Yeah, I don't know what to call the shuttle actually. Yeah, so planetary landings are working in concept, but there's a lot of moving pieces that need to come together to achieve the actual full real-time landing via shuttles. Obviously, we want to be able to go down to the shuttle bay, get into a shuttle, fly down to the edge of the atmosphere, and then have it load in the surface environment and teleport the shuttle down there. The difficulty with that process is it's going to be a multi-step process, in that we've got the shuttle itself, which when you are in a shuttle bay needs to be a physics object. In fact, let's load up the Caravella map a minute. Because it would be good to test it on that while we're doing it. Okay, so the idea is when you're in the shuttle bay and you get in a shuttle, then the object you're getting inside of is a fully physics simulated vehicle where you can walk inside, you can sit in the chairs, you can interact with the controls. I want it to be just as physical as the rest of the ship interior. So when you fly it, you are flying around the literal shuttle bay of the static interior of the main vessel. So again, just so we're clear on how it all works, we have the main ship, which is like the main ship you launch the game with. That's your mobile main base of operations within the game. That's a static interior, and we move space around it to simulate spaceflight. We can't move the interior because it's too huge and it's too full of stuff. So the shuttle, when you're flying it around the shuttle bay, is flying around a static environment, no different than the planetary surface. So it can ram into the walls, it can push boxes around. It's physically part of that world. As soon as you leave the shuttle bay, we have to separate it from that physical world, because otherwise, when you pitch and roll the main vessel, the shuttle is still stuck to it, basically. So you'd see space pitching and rolling around you and the main ship. So the main ship would remain static in space, because you're basically still flying around that static interior. It would look weird. So as soon as you exit the shuttle bay, we have to do a bait and switch. So we will teleport the shuttle wholesale with you and anything that's in it to one of those vertical slots that we'll reserve like 1,000 kilometers down under the main ship, like so far away you can't see it. And that shuttle then becomes a static interior of its own. So the gravity direction is always down. You can move around, you can jump, you can throw stuff about. It's a fully simulated static interior. Now what you see out of the window at that point becomes the same simulated environment that you see out of the windows of the main ship. And then the movement of that environment is driven by a proxy for your shuttle that you're currently in. So there'll be a physics version of your shuttle flying around, bumping into things and generating the movement out the window. And this is necessary so that that shuttle can exist independently in the galaxy. It is its own ship at that point. It's no longer connected to the vessel you left in any way. If you were to turn around and fly back into the shuttle bay, then we do that bait and switch in the opposite direction. We teleport the shuttle into the shuttle bay as seamlessly as we can, and then you are basically then flying around a moving object in a static environment. So there are definitely two modes of operation. Again, if you leave the shuttle bay, you become static. Everything you see is moving around you. You are stuck in the middle. And then if you enter another environment, like the planetary surface, or a space station, or an alien derelict, or any other structure that we want the player to be able to walk around, all of those structures are going to have some kind of shuttle bay, or at least an area where we can teleport the shuttle there and have it fly around as a physics object. And that's basically the three-part transition. So it goes from flyable physics object to static interior object, and then back to flying physics object as you transition through space to environments that the player can walk around. And basically anything the player can walk around must be a static environment, and space must move around that static environment. That's basically the rule, because otherwise it makes simulating physics really, really difficult. So again, the surface of a planet is the static environment, and the shuttle is the thing that is moving. In order to have that be able to be upside down and the players still being able to walk around, we're going to make the player basically a child object of the shuttle, so that when you're moving around the shuttle interior, you're only able to move laterally. You will not be able to jump whilst the shuttle is a physics object. When the shuttle is flying through space and is treated as a static environment, you'll be able to jump and throw things around and everything else, just like normal. When it is a physics object and it itself is flying around, players will essentially be just only able to move laterally around the interior. They won't be able to jump up and down. Because at that point, players are no longer simulating physics. The shuttle itself is simulating physics, and if you as a player were also simulating physics, then you get into that kind of fast moving platform with player physics, and then you have to make sure the player doesn't glitch through this fast moving platform. It makes simulating physics extremely difficult, especially in a networked environment. This is one of the things that is exceptional about Star Citizen, actually, and how they've managed to have these separate physics environments per ship, and how you can be walking around perfectly smoothly and not clipping through things, whilst the ship is, tumbling through space. We don't have that capability here, so we have to bodge it the best we can, and that is by simply attaching the player to the ship and only allow lateral movement. But yeah, so basically, having now explained all of that, you can see that getting from the ship, your main ship, down to a planetary surface using a shuttle is a multi-part process, and we have to perform at least 2 separate bait and switches with the shuttle in order to get the player down seamlessly as possible. The only other way to do that would be to make the back door of the shuttle a portal, and then have the player themselves teleport through that portal into the static shuttle interior. But then that doesn't solve the problem of how do we then fly the shuttle around on surfaces. How do we fill the back of it with cargo and plants and stuff, and have those things be transportable up to the main ship. So by taking the shuttle itself and teleporting the shuttle itself wholesale, it means anything you put in the shuttle will also be attached to it and teleported with it when it gets transitioned from place to place. So that completes the full loop of being able to fly down to a surface, pick up an alien plant, stick it in the back of the shuttle, fly it up to the main ship, then take that out again as a physics object and walk out the back of the shuttle whilst holding that physics object, and not have to go through portals or anything like that. It's it's a complex solution for a complex problem, but so far it's all going well. We just need to handle that last missing piece, which is the transition side of things, because right now shuttles are attached to the interior of the ship that they're in, and we need to break that attachment as you transition in and out the doorway. And I think the first thing we'll do, testing wise, is obviously when you're in the shuttle, it'll be using the landing thrusters to keep the shuttle hovering and all that sort of stuff. Obviously, as soon as you enter space, we need to switch it into 0G mode, where the landing thrusters are no longer used, and it's then relying purely on its RCS and main engines to orient itself. So yeah, we'll do that bit first, get that bit working smoothly. Once that's working, then we'll try doing the bait and switch and see whether or not we can get the shuttle to become a static interior and have a proxy of itself take its place when that teleport happens. So basically, this is what it should look like. You should see the shuttle leave. So if you're a bystander in the shuttle bay watching it go, you'll see the shuttle leave the shuttle bay like this, and then it would flicker. And I'm hoping that the most seamless we can get it is a small flicker, where once it's here, you're no longer looking at the physics object that left the shuttle bay. You're now looking at a proxy for that object, which is being driven by the physics sim version of itself. When that then returns to the shuttle bay, and let's turn that round for the sake of it, you're basically looking at like proxy, 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 and then it enters the shuttle bay, and then it will like flick or flash or flicker in some way, and now it's a physics object with the actual players inside, and it's the actual simulated physics vehicle. So that transition between actual object and proxy object needs to take place on the transition through the doorway. And we just have to make sure we do that bait and switch as quickly and as seamlessly as we can, so as not to break immersion. That's the only way I can think of doing it, basically. Yeah, something like that. To be honest, Ian, that would work. Just, as it goes through the force field kind of flashes and flickers, and at the same time we kind of swap the shuttle out, and hopefully, you don't notice that it's been swapped. But there are always solutions to these things, and that's what's fun about game dev. It's I guess it's what I like most about game dev. It's knowing what you want to do, and knowing that you need to come up with a really clever way of doing it in order to make it work within the bounds of the engine that you're using. But yeah, you're right. I think a flickering force field would be the ideal mask to mask the transition. But it should be quick enough anyway. I mean, we can also slightly offset it as well. So we're like, the proxy object will be there anyway, just invisible. So we can make the proxy object visible like a fraction of a second before we teleport the main thing away. So the transition is like, it's covered up by the proxy appearing. It would probably still flicker in some way. That you'd probably still see something that happened. Something happened. You're not quite sure what. Something definitely happened. But yeah, we just need to manage that and make it not intrusive, basically. So I'm just going to pop. Oh, actually, before I do that, I'll make it a component. Yeah. So pop that on there, which means I can then extract it over here. So there's one. There's the other one. Just need to make sure that object is in all the places it needs to be while we're building it, and it can't remain as part of this mesh, because you can't use the subdivision if there's a child object inside of it. So that should that should give us that same object now, where we can edit it in all the locations that it is. Okay, so we need basically to have that whole section openable, and then I guess we need the box section around that as well. There's going to be a few of these, so we need to decide what things are going where. Yeah, so if we do one there, that's that one, and I'll line these up properly once we've worked out what's going there. So what this is giving us is 3 locations. Obviously that's mirrored, so there'll be 3 reasonably large gaps. That's 3 locations for stuff. So we've got obviously the gravity generator, which I guess we'll put as in the middle as possible. We've got the life support hardware, which I'm tempted to have maybe in this front section here, because most of the, I was going to put life support in the nose, but the bulk of the nose is going to be taken up by landing thrusters and RCS. So we've kind of lost that space to hardware. So if I put the life support systems under the floor there, then that just leaves us some stuff to go under the floor here. I'm thinking probably pumps. I know we've got space in this section for that kind of stuff, but the more you can access by pulling up floor plates, the better, really. Because we want, obviously, we want those things to break at some point, in transit. So being able to pull up a floor panel and physically fix the things within is going to be, a big part of the gameplay. And what we do want to do, though, is we want to make sure that we capture the actual size of the panel, because we want those things to line up. So if we let's grab that whole edge, I suppose. Okay, grab a copy of that. Paste that on there, and that will give us our template. Oh, it's almost lined up. Sorry, Claire, did I miss a question? Why is the webbing, the structural framing as thin as a sheet of paper? Ah, right, yeah, so this is the outer skin, which hasn't been thickened yet. This is how thick it will be, which is about an inch. It's actually 2 centimeters, which is just shy of an inch, but yeah, so it's 2 centimeter thick metal, gold-laced titanium. When we have finally decided on the actual final geometry for the outer shell, then all of these surfaces will be thickened to be this thick, essentially. So you can see it here. So all the framework and everything is all fairly thick bits of metal. Is that what you were asking? Do you mean this stuff? So each one of these is 1 centimeter thick and 2 centimeters deep, if that's the bit you mean. I guess you can see it better on here. So it's a multi-section frame, I suppose you'd call it, because you've got I guess you'd call these the stiffeners. So you've got the sheet metal, which runs obviously around the inside there, and then you've got the stiffeners that are inward of that, and it's the stiffeners that we've attached all the brackets and things to for the paneling. And on the opposite side, in the actual cavity, then you actually have, you can't really see, but you'll also have a framework structure within that. So granted these haven't been like thickened up yet, but there will be individual frames. So, you know, like a boat, it's built with frames all the way down. So you've got stiffeners, sheet metal, frame, and then sheet metal on the outside, which itself is going to be covered in hull plating. So they should now line up exactly with the panel, and that panel clearly needs to be made shorter. So that is just shy of 12 centimeters away, so measure that exact distance on this side. That's more like it. Okay, so we're just making sure that's consistent, and then we'll also have a vertical aspect to that as well. But I think that was actually 1 centimeter too thick. I'm not entirely sure what you mean there, Timmy. Let me build this up a sec, and I'll show you. Right, yeah, so a lot of this, so this stuff, these haven't been thickened up yet. I'm still kind of working out exactly where the location will go. So the whole thing's built with box sections. So having just made this one, for example, if I just move these over, I'll need to align those with the frame. So basically you've got box sections like this, and that creates the cavity for stuff that we're going to, hardware we're going to put there. Obviously this is the underside, the underskin. This will be thickened as well. Yeah, we haven't discussed it specifically, I think. But if I just pop these in here a minute. In fact, let's just chop off these bits in here. Well, or rather than chop them off. Hang on, let's explode all them a minute. Make life a bit easier. So all of these bits basically need flattening up. So we can just trim them back for now. Because we've obviously cut these against the subdivided geometry, so they're not all entirely straight, but that should give you a clearer idea of where we're going with it. So so that tank in particular wouldn't be there. The other ones still should be. So I just delete both. Yeah, so they can move over a bit. This is part of the just the figuring out of what fits where. Yes, yeah, so that becomes the actual framework structure, and then like here, this is a double frame. That's one of the join points, and then we'd have another double frame down this end as well. So, and this one is by its nature a double frame because it's basically the back of the ship there. I'll have to work out exactly how far back that one goes, but yes. So basically like that. So you've got a double frame, which is also forming part of the door cavity. And then a double frame here, which is basically defining the cockpit section. So if you think about it in the way it was manufactured, the cockpit section, the mid section and the aft section, they would all be built in 3 separate pieces and then joined together basically where the double frames go. Just like how they build airplanes or ship these days. Like, you know, like an aircraft or an airliner, they don't build them all in one piece. They're built in these separate pieces and then bolted together, welded together. Once we've finalised the actual lines again for the outer hull, I will be chopping this into 3 pieces, and I'll have actual weld lines visible on the metalwork for where it was joined together. But for now we need to keep it all one piece so that when we subdivide it, it all pulls together nicely. Okay, so if we were to take basically that, and that, and just copy those bits over, to give you a clearer picture of the structure. So you've got the cavity, which will have its own vertical frames in it. The interior skin, the interior skin has these stiffening bars on it, and they also form the mounting points for the wall panels. And under the floor here, this is where you've got the framework box section, which is basically giving the thing its rigidity. So that's the physical structure of the shuttle. And while we're making minor adjustments, I wanted to get rid of those bolt points on there, because we're going to make this a single panel. And the same here. Make that one panel, and this one also will just be one panel. No worries, Timmy. It's this is why we do this, and you know, we love to get into the nitty-gritty details of the structural stuff. Make all these the same colour a minute, so that we're making sure it picks up the same material when we export it. Just for consistency's sake. Yeah, so basically all this kind of light blue stuff is all the titanium metalwork structure of the vessel. And then I guess this is how I've built all of the ships so far, is by defining the physical framework first, so that we know, you know, exactly where things get bolted to, and you know what cavities we have and all that sort of stuff. And then I start filling in the interiors, because you've basically created a blank slate at this point. You know, this is the canvas upon which to build the interior design. Yeah, so we'd need basically a second frame section running horizontally through there, and potentially another lightning hole through there as well, because we want to be able to build and dismantle them in game. When you 3D print a new shuttle using whatever hardware we put in the shuttle bay to do such a thing, it will build the shuttle in layers. So you'll see it build all the structural framework, and then you'll see it build the hardware pieces, and then finally you'll see it kind of putting the interior together. So you'll see the shuttle being built piece by piece, again as if it was a real vehicle. Oh, okay, Claire. I'll see what I can do. No pressure. Yeah, I think we'll do something like that, and then obviously we'll trim that to shape. And then these box section pieces can then go all the way across to there. Oops, that was the wrong way. So we're saying 10 from that side and 10 from that side. Then line that up to there, line that up to there, and there. Yeah, then that would be the second cavity. I guess that's where we'd have some tanks. Well, in fact, it's where we do have tanks, which you can't see under there, but they are there. Just need to make sure I get these ones lined up consistently. Go. Now they're all the same distance away from their respective frame. And yeah, while we're at it, actually, that needs to align specifically with that one. So we try and make sure that the either the floor internal stiffener or the wall ones always align vertically or horizontally with the box section. Again, just for stability reasons. So if I've measured this right, that should be perfectly lined up, which it is, that's good. Which means that, importantly, these two panels and these two panels are geometrically the same, which means they can be copy-pasted in Engine. Just means we're having to model one thing rather than two. So we're not going to be able to have probably any removable panel in the cockpit section because of the chairs, unless we have maybe a small panel down the middle. I'm sure there's something we can squirrel away down there. Ah, thank you. Yeah, me too. I'm looking forward to seeing all of them complete, to be honest. Yeah, I think my main quibble, I suppose you could call it, with this design is that I feel that these gaps are possibly a little bit too cavernous. Like, I feel like there should be additional structural members in there, which we could potentially do, but it really depends on the needs of the hardware, really. So we'll get the hardware in, and then we'll see whether or not we can split them with another bit of frame. Yeah, smuggling space. Actually, see, we've obviously included removable hatches down the middle. I'm wondering whether it would be worth, because those obviously come out like as a hatch, revealing what is underneath. I was just wondering whether it's worth building the framework up to meet that. Or, like, do we need a hatch, or can we just remove the whole panel? We'll see. We'll see how it works. Well, I want to make these sections up here storage bins. So obviously we've got our spare seats in the back, which themselves need to be removable. And then, yeah, some kind of overhead storage there, which will we could build in a minute, to be honest. I was just thinking, actually, so obviously when we subdivide this, it's going to pull that in. You can see this internal ribbing was aligned to the subdivided version of this mesh, so that's why there's a gap. So in an ideal world, you want to be able to cut through there, and I'm thinking maybe we don't subdivide this bit and we use the geometry we've got there instead. I'll leave it for now because it's going to add some complication. We only really need the subdivision around the window frame and this curve here. This bit's, by its very nature, straight, so we don't need, well, I guess we don't need any of the subdivided geometry there. So we could potentially actually get rid of just these bits. Let it subdivide normally for the rest of it, but then make these sections here manual. For the mining shuttles, I'm basically after a flying JCB. I want it to invoke the kind of energy that the power loaders have in the Alien movies. That kind of JCB yellow, kind of industrial metal kind of feel. I want to make sure I align this to what would have been the subdivided geometry. Okay, so we should be able to draw across there in a complete straight line. Minus that bit. If I select all of that, hopefully we should be able to skin it. I think I've got a little bit sticking out somewhere. Yeah, that'll be that bit. There we go, that's better. Okay, so we then thicken that to its full thickness. Actually, I think I'll align that to the middle, and then and then when we do the subdivided bit, we'll just have to smooth off that transition. Basically, we just need to create a stable, easy to work with interior. Okay. Yes, Festus. And yes, Caesar as well, definitely. It definitely needs to have that really industrial vibe. But yeah, we should be able to land on a water asteroid and use that to replenish the ship's water supply via the mining vehicle. Right, so where am I cutting the holes is the question. Obviously we've got the chair taking up the bulk of that space, so really we don't need this panel here, that one. So if we're turning all of that into one panel, then that can be one hole. Then we just remove that to access it, which means we need that edge. So if we align to there, out to there, align to there, come out the same distance. Slightly tricky on this bit because it's on a curve. It's going to cause us some minor grief, but we'll fix that when we get to it. Okay, so what we've gone ahead and made ourselves here is this is the kind of main access into the engines. So there. Just copy them over a minute so we can see them in place. So this is how we get to our maintenance bit. So the idea originally was to put the pumps and the chillers for the fuel in the same maintenance bay with the engines themselves. But I'm thinking it might actually be better to put them in here instead, because we're going to have the landing thruster obviously in here doing what it's doing, plus the thruster assembly for the RCS ports, and then we're making that kind of funky RCS gas manifold thing so we can direct the gases in different which ways. So there's going to be a lot of just engine stuff in here, so I think we'll make these predominantly just engine bays, basically. And we can move the hardware for the braking thruster over so we can get to it more easily, and then just have an extended port leading to the front. So basically we're moving that out. And that stuff would move down into there, which would give it more room to breathe. It means we can actually make nicer looking, less compact pumps and chillers. And then we'd need to route all the fuel lines all up into here. So there'll be a lot of gubbins going on in here. Yeah, so from a maintenance perspective, if you've taken damage and something needs fixing, then the layout needs to be as logical as possible. So we'd have... So if we were putting all of our pumps and chillers in this section, then all the pipe work for that's going to have to go, I guess, through the sides here, which means that all needs to be accessible, which means I guess we also need paneling on this side as well. So if we remove them, least that bit needs to move over here. Actually, let's do that here so we can line it up properly. Okay, so that should be the same distance as it is on the other side. Well, I think we're 1 centimetre off. Which begs the question, why? So that's 14.6 to there, 14.6 to there, so they're in the same place. Must just be the width of the panel. So we need to obviously sort out where these are going to join with each other, especially here, because I think I'm going to lessen the amount that curves in at that point, and have the curve start here, basically at the midpoint in this frame, so that we can keep this bit perfectly straight. Because if we can keep the interior bit straight, then it makes these wall panels much easier to do, which means they can just be straight copy paste, which is much easier. It doesn't matter about the ceiling, that can slip down, but yeah, we'll make that bit straight, which means that all needs just nudging out a little bit. It will affect this window frame here, but not insurmountable. Yeah, so the idea is that each one of these box sections is basically airtight. Obviously the outer hull is several layers thick, so once all this has been thickened, so this is basically going to be 1 centimeter thick titanium gold alloy. So the actual pressure vessel is the outside bit. The only bits that will be exposed to vacuum is these sections here. So where, I guess here, where the engine is poking through, like this, these bits will be sealed off. So this bit here that bit there, that'll all be sealed. And we can also double skin the back section as well. So whilst the interior of the engine obviously is going to be exposed to vacuum, the bit on the inside wouldn't be. That's the idea anyway. Yeah. Basically, that's that's the trade-off. Like, we need to be able to access and repair these things mid-flight when they break, and to do that, you need to get to them. So, without modeling, having to put on a spacesuit, depressurize everything and go through all that rigmarole, it's easier just to hand wave the fact that there's really good seals around things. Ultimately, it is only 1 bar of pressure. It's not exactly we're not talking like submarine pressures, but yeah. In 200 years, we've got really good sealant, and it really helps keep the air in. Saying that, the ISS has had a leak for years, hasn't it? I think that thing's been slowly leaking for decades. Yeah, and fixing wise, it's bolts. They are bolted on, and all the panels have rubber on the back of them as well. So every panel, sorry, camera's going mad. Every panel has got a layer of rubber on the back. So where they're squeezed into the frame section, you could argue that that rubber is also kind of helping keeping air in. They should be airtight all the way around. But yeah, obviously if you do remove one, then you're one step closer to hard vacuum. Yeah, I think media and films have kind of over exaggerated how much pressure there is. Like, it's kind of, they say that your entire body could be sucked out through a tiny pinprick in the side of a space vessel, and no, there just isn't that much pressure. It's only 1 bar of pressure. It would probably hurt, but yeah, it wouldn't suck you out. Yeah, space is one bar. So, I mean, you could probably put your hand over a hull rupture and keep the air in. Obviously, it would hurt because you'd have 1 bar of pressure sucking on your hand. But yeah, I reckon you could probably do that. Yeah, for sure. We'll just yeah, we're just gonna have to hand wave it with just really good seals, basically. Okay, so I think that's pretty much those panels that we need for now. So this gives us access to the braking thrusters, the main engines, and the RCS from here, the landing thrusters at the back. I suppose technically we don't need an access panel on this side because there's going to be nothing here other than the pipes that are flowing through this side. But the landing thrusters in the front, and the RCS are going to require utilities, which I guess we're just going to have to pipe along this edge. So I guess it would help if we kind of visualized where they are going. So we'll compactify the design a little bit. They don't need to be this chunky. Actually, if I recall correctly, I think I put them 2.8 meters in from the center of mass. Now it would help if I knew where that was, so let's just draw that in a sec. Yeah, so our center of mass is there. Let's just draw a little widget so we've got an idea for that. Yeah, I'll give you a very quick demo. So what we're positioning right now is the 4 landing thrusters. So it's come on, give me the widget. These green thrusters underneath. Obviously they need hardware generating them, and the same in the nose here. So we need to generate the hardware that is generating this thrust. So when we are actually flying the thing, hang on, let's make that bigger a minute. Come back, come back. Yeah, so the flight is handled basically purely by the 4 landing thrusters using an FPV drone style stability system. So it's not using the aerodynamics to stay in the air. The aerodynamic wings are there just for stability during atmospheric entry, and for a little bit of downrange guidance, but predominantly the only thing keeping this thing in the air is those 4 thrusters underneath, which is why if we tip sideways, we start going sideways, because it is literally flying like a drone would, or a quadcopter type of vehicle. Obviously, if you fire up the main engines, then you can fly around more expediently. It's actually quite fun to fly. It's a little bit tricky, but nevertheless quite fun. Oh, too far down. No, no, get out of the water. But yeah, so it's hovering around on its little landing thrusters, and I'm going to hit the bank, and then I'm going to hit a tree, and then it's going to nosedive. Actually, if I get out of it now, let's see how effectively it can sort its life out. Go gadget clipping. Oh no, I've knocked it into the sky. Go back. Yeah, so you can see there it's hovering on its 4 landing thrusters. This is on the dev build, yeah. Yeah, we definitely need it to shut those engines off at a certain point. Right, so our centre of mass was there, and I think, if I remember rightly, it was 2.8 meters. Yeah, there. So same thing that way. So centre of mass, 2.8 meters. Oh, no, that's 2.8 centimeters. Hang on, let's do that again. Something went awry. Oh yeah, we lost our nozzle, basically. Try that again. Right, so that's our centre of mass. So we want one to be 2.8 meters that way, and then the other one 2.8 meters that way. So that's where the thrust physically is, and we rotated that over a little bit as well. So I'll get the rotation right. So they're not firing directly straight down; they're firing at a slight angle. Yeah, and that will be kind of there. So that's basically where the thrusters will be. Just angled into the hull some more. So we just need to make sure that we've got room enough for those engines. I will reduce the structure, I think, of the engine itself. Make it slightly stumpier. Yeah, the planets in the dev build are disabled at the moment. We could go down to them at one point. So the planet modelling is basically there. The atmosphere and location in the galaxy side is done. So when you're on a planetary surface and you look up, the stars that you see are the real stars for that point in the galaxy. So all that bit's done. We've just disabled them for now because we have no way of getting down to them with shuttles. We had to teleport from a temporary portal. Once the demo update's out, I'll put the planets back in again on the dev build, because we're going to start working on that pretty much full time soon. Yeah, because we need to do. So to get my head around what order we're doing things in. So we need the sublight flight model done and polished. It's pretty much there already, so when we move on to that, really we're just polishing it off. That gives us objects in space that we can approach up close, as well as things like wormholes, because we need to be able to collide with them in order to initiate going into them. That gives us creatures in space, like space corals around planetary rings. So all that stuff really is dependent on the subflight model, because we need the ship to be able to interact with those things physically. That also gives us other ships in space, because again, you need to be able to physically interact with other things in space around you. So the subflight model is kind of a big gate between stuff that we need to add. Once we've got that reliable mechanism for piloting the shuttle in and out of the main vessel, then basically we're full steam ahead on planetary landings at that point, because that kind of opens the door to being able to get the shuttle down there, in addition to generating like alien structures and things you can land on. So there's lots of exciting stuff coming that's based on what we're doing now, basically, or in requirement of it. Okay, so the RCS, the idea there is we're going to have basically a smaller version of this kind of in the wing. Just going to move that down there a bit. I need to move that over slightly. But yeah, so basically we've got our plasma rocket, which is going to be manifolded on the end. So rather than a single nozzle, we'll have like a manifold that goes in different directions with basically plasma valves on it. So we'll have a constant thrust coming from the motor, and then we'll be opening and closing different valves to redirect that thrust where we need it. And the same kind of deal in the front here as well. So we'll probably have maybe a horizontally mounted motor, and again have the RCS ports be a manifold, like a spaghetti mess of pipes on the end of it for the individual output ports. So on that note, we're going to need another one of them. Yeah, it's probably something not a million miles from that, just smaller, for the individual ports themselves. And again, these ones will have to be angled. I think I use 30 degrees, if memory serves. Maybe it was 15. Yeah, I think it was 15 actually. Yeah, so about 15 degrees on an angle, and the same with this one. We could also, to be honest, angle them forwards and backwards a little bit too, just to give it that more stable footprint. Let's see how that feels actually. So we could do something like that. Should be angled outward. So you're creating more of a stool kind of arrangement with the thrust. The nice thing about going like full simulation with it is that you can just move a thruster and that will immediately change how the thing feels to fly. So I would expect to be a little bit more stable having those forward and back facing thrusters. Yeah, it's still quite twitchy on the pitch, but yeah, it does feel a bit more stable. It's not like overcompensating like it was. Trees, pull up, no, get out the bush. Yeah. So the pitch and the roll are handled purely by the landing thrusters. So obviously it's turning them on and off and cycling them up and down to handle pitch and roll. And then yaw is handled purely with the RCS thrusters. Because obviously you can't induce twist with 4 thrusters pointing down easily. And then yeah, up and down obviously is just using the landing thrusters as well. So yeah, I think yaw was the only thing that was using the RCS. Everything else is just literally those four landing thrusters. Just need to work on pressing the right button and making it not quite so twitchy. Uh-oh. Mayday, mayday. It's going to be fun when we add a damage model, because I'm going to be going through many shuttles. Yeah, I think the main difficulty with it is obviously because we are dealing with just those 4 thrusters. If you like tilt too much to one side, it loses all control authority. I'm sure it's going to be significantly easier to fly with a HOTAS, because then you can do nice graceful analog inputs. I can do that again. Yeah, so every time I try and bank into a turn, obviously, by banking into a turn, I'm treating it more like an airplane than I am a drone. But the act of banking like that, you're losing altitude when you do it. Because essentially you're kind of falling down sideways, so you need to be able to combine that with upwards thrust from underneath. Yeah, because that's just basically just sliding sideways towards the ground at that point. Completely losing altitude. Okay. I don't think there's going to be a lot practically that we can do about that in terms of how it flies, because ultimately it is a flying brick that's held up by 4 thrusters. So there's going to be a certain lack of elegance in it. But that aside, I don't think it's terrible. As long as you don't try and pilot it too roughly, It does hold up fairly well. You could probably even get away with a barrel roll, as long as you're quick about it. Yeah. Maybe you could get away with one of them. No. Shuttle doesn't like that. Again, because we don't have wings and we are essentially a flying brick, we don't have the aerodynamics needed to be able to do a loop. Because as soon as we try, it immediately tries to right itself because of the PID controller. Yeah, it seems to be able to handle that gracefully enough. I think that's it. As long as you just give it room to be able to recover altitude, it seems perfectly happy. I guess the challenge from a design perspective for the game is making sure that the shuttles and all kind of atmospheric vehicles offer a suitable amount of challenge for people that like flight sims, and have them easy enough for Claire to fly. Not singling out anyone, individually, but someone who doesn't like flight sims and isn't going to be interested in fine flight controls. They need to be easy to maneuver. Basically, if balls. We appear to have had a mishap. Yeah, I think the litmus test is if Claire can land and fly around a planet in the ways that I can't, clearly, because I keep crashing into stuff. And then we'll call it job done. And it will never fly again. Yeah, the whole thing's going to be thruster based. It's desperately trying to turn itself over. It's just not going to be able to do it. I don't think I can give it a helping hand either. Oh, well, maybe. Come on, there you go. Oh, almost. Come on. Oh, I think it managed it. It's leaving without me. Oh, now I'm stuck in a tree. Shuttle? Shuttle, where did you go? No, it's gone. It's left. So this also brings up, some interesting points with planets and landing on planets, and how we handle the gameplay of being on a planet. Now, obviously, our primary focus is that of exploration. So we want to be able to land in the shuttle, get out, explore on foot. but the surfaces, they're going to be densely populated. Well, certainly on atmospheric worlds, there'll be densely populated environments. And you've just seen how easy it is to lose a shuttle. Like, if you park it in the trees somewhere and then wander off, like, you're never finding that thing again. And you'll spend the rest of your days just stuck on a planet with no way home. Seriously though, where did it go? It wasn't flying away that quickly. Yeah, so we need to make sure we've got mechanisms in place for being able to, target the shuttle and find it again. Remembering where you parked, because planets are big and forests are dense, and pilots are dense. Yeah, oh, there it is. There it is. It went off on a sightseeing mission. Not that you can get back in it. But yes, recall and have it able to land. I think, yeah, definitely is necessary. You need to be able to call the shuttle over to you. In which case we need the autopilot to kind of lock onto your location and successfully navigate its way there without bumping into things. I think to aid in that process, I'd probably flag the shuttle as being invulnerable during that process, because it would suck if it hit a tree by accident and exploded. I think just some kind of radio transmitter would be good enough. If it's sending out a signal and you're sending out a signal, then triangulation should be easy enough. Yeah, I'm not getting back up to that. But yeah. So I definitely think rotating them forwards was a good idea. It definitely helped with the stability. Okay, so I'll have those angled outward like that. Yeah, so it's going to be quite complicated plumbing in here, because we've got essentially 4 engines there and another 4 in the front. Obviously it's doubled across. So there's quite a lot of engines that we're feeding. Probably from... yeah, 2 sets of hardware, because if we get rid of those and simply make these bigger, so we can make them kind of proper full-size objects. So basically you've got your pump and your chiller hardware underneath the floor there. And obviously this is only half a shuttle, so we'd have the same mirrored on this side. So you'd have the pump and the chiller for all the stuff on this side of the ship, and then the same pump and chiller for stuff on the other side. Or we would just have one of each with more complicated piping and kind of manifolds and splits. Okay, so think they're going to have to be the main tanks, and we're also going to have to shorten them slightly because we need we need the pipework basically going in one end and coming out the other. Yeah, then I guess have them at the full length. So that's basically the entirety of our fuel tankage. We could, I suppose, maybe have pumps at one end, chillers at the other. So we've got a pump and a return. So that basically becomes the fuel pump. Although, that said, actually, we need coolant, don't we? So we do need two of each, because we've got the fuel pump and the chiller that basically recondenses the gases back into liquid storage. But then we've also got the coolant, which needs to do the same. So again, we have a coolant pump and our recondenser. So we do need two of both. So we can have one set there, one set there. The gravity generator can go in the middle here. And we've not defined what that is or what that looks like yet. So let's do that. So the idea we had for how gravity is generated on the ship is basically we have a mesh of a certain element in the floor panels, and when that's energized by a field that's generated by the gravity field generator, which would be this thing, when that's kicking out the field, those floor panels are energized, and that creates a gravity-like effect. So it's not true gravity, it's gravity-like. So it has a similar effect to gravity, in that it keeps you kind of stuck to the floor. Kind of a cross between gravity and magnetism, something like that. So that the floor plating itself is not generating gravity, and this thing here is not generating gravity. In unison, the field that it generates and the energized mesh work together to create gravity. So each vessel would have the field generator, and all the individual floor panels just have that mesh built into them. So they just have to be in range of an active generator in order to create suck, as it were. So yeah, we'll have to make that look sufficiently sci-fi, with flashy lights and a glowy dome of some kind. So electrical generation is an interesting one. On this shuttle, because it's so small, we really don't have room for any kind of reactor. So we're going to go with batteries. So this thing's basically rechargeable. You'll plug it into the main ship when you land, and it will be fully charged next time you need it. We won't make it so that the electrical charge is difficult to maintain, because ultimately we don't want that to become like a serious concern, having it run out of energy. But we'll have it like the panels on top will be photovoltaic, and they'll be able to trickle charge the batteries, and it'll be the same solid state batteries that the main ship has. Yeah, I don't see why not, to be honest. Whilst the engines are running, there's no reason why we can't siphon off that energy. I mean, these things are practically fusion rockets, so they're generating a lot of power. Obviously, they also need power to run because everything's electrical. The gravity generator's electrical, the engines are electrical, the whole thing's electrically powered. Yeah, so one of the calculations we did for the Magellan and the Caravella is we worked out how much cubic centimeters worth of plasma is needed in order to produce X amount of energy. And I've got that written down somewhere on one of my spreadsheets. I need to find it and dig it out. If the cubic volume of plasma is small enough for a shuttle of this size that we can build a reactor that is small enough to fit in the floor cavity, then yes, it can have a reactor. I suspect that the reactor would have to be bigger than the space we have based on that calculation, and I want to keep it consistent so that every reactor that's in the game adheres to the same cubic volume energy generation math, so that we can scale reactor hardware based on the cubic volume of plasma needed to generate the power that's needed. And then when it comes to alien devices, they might have a greater energy density, so they can generate the same amount of power in a smaller package. And that's how we can do upgrade paths, and how we can make maybe alien vessels of certain species a lot more efficient in terms of how they use space, because their energy generation technology is that much smaller. And it just it creates the interest and the intrigue in the alien tech and how it works, which is all good fun. But yeah, for human vessels, we'll have our limit on just how much plasma is needed to generate the energy. We have a lot of cavity left over in here. Obviously, once we've done the engine side of things, we've got a lot of empty space that we can use for lots and lots of battery banks. So we can put them in there on both sides. Obviously, we still need to fit in the life support systems. So there's either going to be some spare space in the nose, which there might actually end up being, because we've got, when we were experimenting with it, and I guess case in point, that actually does fit. We had this big old oxygen tank in the front there, and that actually does fit quite nicely, even with the RCS thrusters. So we can fit all that in there, but you can't get to it because it's behind all this stuff. If we can make a hatch you can open to get to it, that could be interesting. Because we want, again, from a gameplay and drama perspective, we want things to be able to break and cause problems and need fixing. If the life support breaks on the shuttle, then that creates drama, that creates gameplay. Something needs fixing. If you don't fix it, you're going to run out of atmosphere. So that creates tension. But we need to be able to get to that stuff to effect a repair. So we also need some kind of limited 3D printing capability, which again we could actually have in one of the side sections, or even just as a general utility thing in the shuttle. Because I've gone with a symmetrical design where we've got a seat on each side, but there don't necessarily need to be two seats in the back. There could be just one, and then one side could have genuine utility stuff like a 3D printer, just a small 3D printer for use in the field. So if you have something you really, really need and you don't have, having a 3D printer there could actually be a lifesaver. So that might be a good way to go with that. Because if you suddenly need a component for something and you don't have a way of making it, then having a 3D printer in the shuttle would really save your bacon. We'll think on that, because that could be a good way forward. Okay, so we've got that thruster, those ones are all there. Again, we could potentially move the pumps and things into this cavity. Yeah, I was toying with the idea of requiring an EVA to get to things. So it's not beyond reason. With the shuttle being a static object once you're in space, yes, that's not impossible. We can simply have an EVA suit that you can use. So we could have something like underneath the front here somewhere that you have to access. But I'll try and make it so as much stuff is available on the inside as possible. Yes, bacon is printable on the main ship. I'm sure I can print a Twinkie as well. Yeah. Yeah, it's there's this like point where you have to draw a line, isn't there? So we look at the mission spec for the vehicle, and you know this is in very much in every way a small bus. So the idea is that you have a selection of crew plus a pilot, and the job of this vehicle is to get all those people from point A to point B. And then obviously we can add some extra stuff like a med kit and basic maintenance abilities, but there has to be a point where you draw a line and we don't make it a fully self-contained survival vehicle, because that's not its role. Its role is literally a bus, it's a taxi. So maybe a parts locker as opposed to a 3D printer. So you leave the ship with a locker containing the most likely things that you'll need to replace things with. So you'll have spares. If you run out of spares, then you've got a problem. I think that probably makes more sense than building a 3D printer into it, actually. The operational range needs to be main vessel down to a planet's surface, practically unlimited traversal of a planet's surface. We don't want it to like run out of fuel and energy within half an hour, because we want people to be able to spend time exploring, and then obviously get back to the main ship afterwards. But that's basically it. So it is a short-range vehicle. It won't have FTL capability. You won't be able to fly from a planet to a moon, for example. So it's very much low orbit down to the surface and back to low orbit. Nothing further than that. Oh, thank you. Very much appreciated. Have a heart. Yeah, there's definitely an argument to be made for having a 3D printer. I think if we can make 3D printers small enough and ubiquitous enough, then it wouldn't be out of the question to include one. Maybe in the same way that like a little microwave, you just open the door and hey, it's a 3D printer. And I think the only place you could possibly put one would be in the utility section in the back. And you'd have to sacrifice one of the chairs for that, which I'm happy to do. I don't have a problem sacrificing a chair for for utility and functionality, but we do need to draw a line somewhere. So the capabilities we have can't be too powerful for a vessel of this type. It needs to be able to look after itself a little bit, but no more than that. That is true. I mean, the Magellan's got like 12 shuttles in it now, probably, if not more, because there's plenty of space for them. Which in itself could be interesting gameplay-wise. Having an off-world team like stuck somewhere and you having to go and get them, that could be quite interesting. You could do, but I don't think you could be able to get to it. That's the problem. We definitely need to reserve these lockers for EVA suits, because there will be planets that you're landing on that will require a suit of some kind. In fact, I would say more often than not, because planets that have not just an oxygen nitrogen atmosphere of the right composition, but also the right pressure for it to be breathable. And I didn't really learn about this until last year, about the window of breathability. So the ratios of oxygen and nitrogen and every other part of the gases, the ratios differ based on pressure. So anyone that does like scuba diving would probably know all about this, but oxygen isn't just oxygen at certain pressures, and your ability to breathe is pressure dependent, and that means that for probably most of the planetary atmospheres won't be naturally breathable, so you will need a suit for those. So having suits in suit lockers is absolutely imperative, I would say, because you'll need them more often than not. So the question then becomes, how many can we fit? I guess we've got what, 2, so we've got 6, 8, 10. So if we had 10 people maximum, you could probably only get 8 suits on here. Yeah, which would be a challenge. Yeah, I guess unlike Star Trek, though, we're landing on every planet, and it makes sense that all the places they visit are breathable because that's why people are there, and they're not going to all the places where you can't breathe, but we are going to all the places you can't breathe. I guess that's the point. Oh, the larger shuttle will have a lot more stuff. Not least of which the vehicle bay, of course. So along with the vehicle bay, I think maintenance stuff, definitely. We want that larger shuttle to be a lot more capable. So if you land that on a planet, that's like very much a mobile base. Right, so we did that. Let's grab this tank a minute and move it into the right layer. What layer is it even in? Yeah, there's going to be some complex frame geometry around here to hold all this stuff. So if we make that one, I guess those ones, if we make those unique a minute. Get rid of those end bits. Probably more size-wise what we'd be looking at for the landing thruster. So we need, I guess, four pipes per thruster, because we've got the two coolant feeds, one in, one out, and then what we will have is this bit at the back, which will be the gas intake. So there's 4 pipes there. 2 of them come from the fuel feed. 2 of them go to the coolant feed. Yeah, so we're going to need a bunch of labelled pipes with all that going through them. So we're going to need I guess we're going to need a single pump that goes to a manifold, which then separates that out into all the different places it needs to go. And then we need like an inverse manifold the other way to recombine all that into a single feed for the compressor, or the chiller, which puts it back in the tanks again. And then we need that twice because of the coolant. So yeah, ideally it'd be good to get some kind of panel access in the middle there between the chairs. It's just going to be very small. I'm not sure what we can put there, to be honest. Yes, we do want to include backpacks. We haven't worked out how specifically we're going to manage the inventories yet. It's going to be largely a physicalized inventory, so it's going to be a case of belts, holsters, that sort of thing. Obviously a backpack gives you more kind of free-form storage, but we'd probably do it by way of physical slots as opposed to like a weight-based system. I loathe weight-based systems that slow you down when you're carrying too much stuff. That drives me mad. So I would rather have a slot-based system where if it doesn't fit, you can't carry it, as opposed to getting slower and slower and slower. But yeah, you'll have lots of different belt slots and all that sort of stuff. We'll have the number keys on the keyboard basically be the quick slots, and those will be the belt items. So you'll have things like engineering tools, weapons, medical tools, any kind of handheld device that you'll be using will be belt mountable, and you'll be able to just grab tools off the belt as needed. Something like a backpack would be for more for things that you pick up on your journey, I'd say. Yeah, and that's basically where the belt idea comes in. So a sidearm would have a holster, so that's where it would live. It would live in the holster. A rifle style weapon would live on your back probably. So we'll just have like a grab it off your back. And yeah, and all the tools basically go on a tool belt. So everything will be belt clippable. But yeah, we need to think about the backpack and how to manage that. I guess a backpack and the kind of things you'd put in a backpack is a very separate thing to things you use tools wise. I really like the forest and the way they handled the inventory in that. It was quite cool. Yeah, and I'm the kind of person, like when I'm playing Skyrim or something like that, I pick up everything. And like one of the first things I did in Starfield was literally pick up everything. Like if it's not nailed down, I'm going to pick it up. So yeah, I always get incapacitated pretty much immediately. Exactly, Ziza. Yeah. So I like that split between things you use go about your person, things you're carrying would go in a backpack. So if you find an interesting rock or you find a small little squirrel-like creature or something, stuff it in your backpack. So I'm just while we're talking, just trying to get my head around the best place to put certain things, and I'm thinking it might actually be useful because the size of the tanks don't necessarily matter, because we're not modeling the amount of fluid that's being stored and used, just the fact there is a tank. So the amount of volume the tank can hold is kind of arbitrary. Although, that said, obviously it's storing cryogenic fluids, and we're only using gas for the plasma, so a cryogenic fluid can produce a lot of gas. Yeah, so if we were to have that basically be the fuel path, so it goes out one end through the pump, goes through a manifold which would be behind here somewhere, so that's basically just going to be like an elbow joint going through there, gets routed to where it needs to go, and then on the return path you've got the kind of inverse manifold on this side, and again like an elbow joint coming in here. It gets chilled with a chiller and then put back into the tanks. So that gives you the full loop, and obviously we can do that at port and starboard. So we've got physically isolated pumps and chillers. So that's one way of doing that, which frees up a couple of areas for things like life support. So things like the CO2 scrubber, we could then put that in one of these cavities, and just have that pipe through to the tanks and things which we store elsewhere. we don't need visibility of the tank. We just need to be able to see where its pipes come out for the CO2 scrubber. And obviously we'll have, I suppose, the full life support section, to be honest. So we'll have like an air pump there as well, which is pumping like HVAC around the place. So we'll also need HVAC conduit too, to some small extent. And obviously the gravity gen can live in the middle, and then maybe put the coolant at the back. So right now it's under there. Or we could actually do something like that. And then have slightly smaller pumps and chillers for the coolant loop. So yeah, so basically everything down this side will be fed by this fuel and this coolant, and then everything down the other side will be fed by its equivalent, which means we've got room enough then to put the life support hardware in this cavity here, run all the pipes and things through to this, which to be honest can live under the floor, doesn't need to go in the front then, and that frees us up for stuff in the front. And that actually leaves us with some spare space. Although we could and probably should use this space for the door controls, the door motors and things. Yeah, I think emergency supplies, that's not a bad shout actually. Put them a floor cavity would be good for that. So if that's our CO2 scrubber, and that needs to have its own little tank attached, because we're doing that metho-what's-it-amine stuff. Stuff I can never remember the name of. So that would be all of our life support hardware there, and then I guess adjacent to that we'd need the pump for airflow, and that would have all the HVAC conduit associated with it. So I guess we're past that through the scrubber. Yeah, so I guess we'll take the oxygen from the tank, and we'll pump that into the atmosphere via the air pump here, and we'll just have some vents and things up in the ceiling for that. We'll route that under the floor and up the side there to the ceiling vents, and then we will also route the return air through the CO2 scrubber and put that back into the same air pump that's pumping the air around. So this thing will be sucking air in, this thing will be blowing air out to give us our full cycle, and then it will be basically sipping from the oxygen tank as the oxygen's being depleted. So the job of this device here is basically constantly pushing fresh air out into the vessel, and then this one is sucking in the dirty air, and then the cycle keeps it fresh. So I guess this would be monitoring the oxygen levels in the air coming from the CO2 scrubber, and then as required it'll be grabbing oxygen from the oxygen tank to make sure that the air it's pumping out is properly oxygenated. So that works. So we can probably just add some frame there and keep that section literally just as frame underneath. Plenty of storage there for the oxygen tank, so that's fine. And we don't need to actually get to it for anything, so that's good. Yeah, I guess we would use ullage gas from the oxygen tank as opposed to a pump, because if we store it cryogenically, then obviously that's going to be boiling off, and that boil off is what's feeding the airflow into here. If we store it cryogenically, of course. We'd store a lot more oxygen if we stored it in liquid form. But we'll see how we go with that. Yeah, and then storage lockers at the back, so that works, I reckon. True. Yeah, I guess the ability to use water for an oxygen supply, it is a nice safety thing, because you can replenish that from any body where you can grab water from, although that does take power. I suppose speaking of power, we could do with some capacitor banks, couldn't we? So if we stick them in here, guess we need to decide like how many battery banks and where. Although I think that's probably the best place for them, in the walls there. And then I suppose we also need a breaker box. I guess that's something we could have under here, to be honest. That could be one of our floor panels. Just have a breaker box under the floor. That's nice and small and compact. Right, so engines, power, oxygen and CO2 scrubbing, coolant, and the associated pumps and chillers therein. It's going to have to be smaller. Can't see it. Easier to do that. So we'll adjust the size of all this stuff as we go, of course. Make that a different colour so we don't get it confused with the life support stuff. So, coolant, fuel, life support, gravity, power, and cargo, I guess. A little cargo hold there. And then there will door motors there as well, I suppose. Cargo / door motors. It's going to be a very interesting job piping and wiring all this up. It's going to be a lot of pipe work for all these engines. Okay, so we've done that, we've done that. Yeah, one of the things I was going to do was look at those lockers or just storage bins up here. So let's see what we can do with them a minute. I guess we'll make them quite big. I was thinking something kind of like that. Obviously we need to fit those chairs in. I might have deleted the spare chair. Did I delete the chair? I did delete the chair. No matter, I shall make another one. Really didn't like that. Something's stuck into a curve here. Ah, there we go. It's better. So I guess we need the overhead storage, which needs to be some kind of I guess aircraft style flap that you can open. But then we also need like helmet storage as well. So I suppose before we can properly scale that, we kind of need to know how big the helmet's going to be. Let's just put that back where it was a minute. Oops. Let's see if someone's made a helmet we can borrow. Anything look suitably astronauty? Guess that's the closest one, isn't it? But it's going to be enormous. Yeah. Come on, give me centered scale. Ah, there we go. let's say something about that size. Yeah, so I guess we'd be looking at a 6 maximum of EVA suits. We'd have them just kind of like on some kind of rack in the back there, with the suit itself in a locker above. So we could actually split this panel into like 3 storage lockers for that. I mean, it carries 6 passengers, so I guess the pilot doesn't necessarily need a suit because it's the passengers that are being offloaded. But yeah, that does limit EVA capability, unless you come pre-EVA'd, I suppose. Yeah, I guess there could be room under the pilot's seat. Yeah, I guess something a bit like that. Yeah, I mean, it's probably more practical to have the team already prepped for EVA if that's what's going to be encountered. I mean, because if you're sending a shuttle down to a planet that you know doesn't have a breathable atmosphere, surely you'd go equipped, wouldn't you? You wouldn't go and expect to find out when you get there. So, yeah. Maybe we just have spare EVA suits in the back. No worries, first just have a good one. Yeah, to be honest, we could put storage underneath the seats for helmets and things. Just have like a stowage rack under there. Again, if we're using this just as a rough example of size, then there'd be more than enough room under there. Yeah, so if we were to build the seat with like a storage basket underneath, then yeah, you could literally just take your helmet, shove it under your seat, and it sits there until you land. I prefer that. And then we'll work out exactly what storage we need at the back here, like what storage and why. Yeah, now we have these so that they flap down. Have them sort of open like that. That could work. Okay, so storage bins at the top, seat there, hooks and things, I guess, for stuff that's needed. Obviously, we've got our floor attachment points for cargo if needed already. Okay, yep, I think that's reasonably good. Yeah, true that. It's oh, I like the idea of a recharge point. Yeah, I mean, because you've got obviously honking great big oxygen tank, so yeah, it could be the case that there are a couple of ports per seat, where you can just like plug a couple of cables in, just have them like on extendable wires, for charging your suit and like replenishing the oxygen supply. That could be quite cool. I like your thinking. So if we were to do something like that. Yeah, just something like that, I guess. So you'd have a couple of ports on the side of each chair, and you can just plug straight in. So something you just pull out kind of like a flexi hose and plug into your side. Stick some LEDs under it and some labels, make it all look techy. It's true, it's true. It's inspiration o'clock. You also need that wall panel as well. See you, Delta. Have a good one and enjoy. Ooh, there's a spider crawling up my wall. That can go away. Be gone. Yeah, the so I showed it on the last stream or a couple of streams ago. SpaceX pressure suit is really good because it's really compact. Obviously, it's just a pressure suit. I don't think it has its own oxygen supply or anything. Trying to find a decent picture of it from all angles. So when Jared Isaacman did the spacewalk on the Dragon capsule, that's obviously the SpaceX pressure suit, and well, he must have had an oxygen supply in there, obviously. But it's really compact, and I love how like maneuverable and everything it is. I think it's definitely kind of the direction we're going in. We want something where the crew can move about unhindered and yeah, not be bogged down by bulky suits. It's a really nice kind of stylish suit as well, and the helmets aren't too big and the suit's not too bulky, and I think something along these lines definitely. And I like the amount of visor space they have as well. It's not restricted vision wise. But yeah, so having just a really like form-fitting lightweight suit with a small amount of structure for things like tanks and stuff that don't encumber you when you're sitting in a chair. So that like the battery pack, the oxygen supply is all built into the suit, so you can just plug in when you sit in the chair, and yeah, that recharges it all, and then you can just head out and do your EVA activity, and just kind of come back to the shuttle whenever you need a recharge. Yeah. Okay, well, on that note, we shall leave it there, as it's just gone midnight here in the UK. Yes, we will continue with the NPC stuff, and hopefully I can get that sorted out without it continually crashing the engine. And at that point, you can put a dev build out, and I'll see if I can get this test level loaded on the main menu for testing on the dev build, so you can hop in the shuttle and fly about the place, and let me know what you think of the controls. Right, so with that, I shall wish you all a happy week ahead, and I shall see you on the next one. Bye for now.